So for your digestive system, you're probably most familiar with yours, simply taking in food and pushing it through the system with systematic breakdowns of the macromolecules and so on as we go. And what we look for is these kind of accessory types of organs. In your mouth, you have salivary glands, of course. And then associated with your small intestine and stomach, we're going to see gallbladder, liver, and pancreas contributing to the process as well. The other key feature for your system is we prevent backflow of food, and we do that using sphincters. So sphincters are round muscles that are going to close off. You see one here at the end of your stomach, or at the end of your esophagus, beginning of your stomach, and then one between your stomach and your small intestine. So we're going to regulate flow of food with these sphincters. So they're going to open and close as need be to let things move through the system. And the thing with the sphincter, particularly between your stomach and small intestine, is we don't want food moving out of your stomach too quickly. It needs to go through some grinding and chemical breakdown before it can actually move into the small intestine. So this is a regulatory mechanism. In your mouth, of course, we have salivary glands. You produce about 1.5 liters of saliva per day. Saliva is about 99% water, and it's going to also have some ions and buffers and antibodies and digestive enzymes and so on. This will actually start to break down food through a process we know as mastication. This is a fancy word for chewing. Mom always says to chew your food. Do it. This starts the process of digestion. And then the saliva's other role here is to actually clean your teeth. This does not substitute for a toothbrush. However, it does help us keep bacteria to a minimum in our mouth. The pharynx is actually going to be full of muscle. This connection from your mouth to your esophagus, so the pharynx is in between, is actually helping us to move food down. So when you swallow, do a big swallow, you can feel your throat moving. That's what's moving. Your pharynx is squeezing and pushing things down into your esophagus. So your esophagus connects between your pharynx. Esophagus is in between, and then it ends at your stomach. You notice that your esophagus is only about 0.8 inches in diameter, so less than an inch. This is important because it's very stretchy. It needs to be so we can actually go through something known as peristalsis, which is the contraction of muscles to help move food down into your stomach. And that squeezing of the muscles will be less effective if that opening is larger. So this really is to control and help move things down into your stomach quickly. Your stomach itself is full of folds known as rugae. These folds actually allow your stomach to expand and hold about a half a gallon. This may not seem like a lot to you, but the next time you have a half-gallon container in your house, hold it up to your body. That's how big your stomach can get. Now, yes, depending on the individual, they may be able to hold much more than that, but for most of us, that's what we're looking at. Here are those rugae I mentioned, all of these folds and wrinkles inside your stomach that actually allow it to expand. The sphincter that we were talking about earlier that's going to control movement from your stomach to your small intestine is this one right here, the pyloric sphincter. Pyloric is stomach. Okay, so that's what we mean there. The stomach, of course, is going to do some temporary storage for us. It's going to help us mix things up. It will do some absorption, but primarily it's only things like alcohol. We're not absorbing other macromolecules very well, or any monomers even very well through here. The digestion of proteins will start because it turns out that this is a long process to digest proteins. So we'll have to actually start that pretty early on. The stomach has to protect itself because, as we've talked about, the pH of the stomach is about 2. So the stomach has to protect itself, and it does that by lining itself with a secreted mucus. And that mucus is actually going to coat and protect the inside of your stomach so that you don't eat your own stomach. What happens if that mucus layer doesn't work right or isn't produced properly? What happens? You develop an ulcer. So this is literally your stomach acid, that hydrochloric acid, that is going to maintain this pH of 2 so pepsin can actually work properly and break down proteins in your stomach. But in its absence of this mucus, this ulcer forms, and this is literally your HCl in your stomach eating your stomach wall. Of course, this is a very bad thing.